Welcome to another episode of Terry's Notes, and today we are going to be looking at vectors. Okay, so the first thing we need to know is what is a scalar quantity. A scalar quantity has magnitude only, and examples of scalar quantities are energy, power, mass, density, speed, and distance. So these are all scalar quantities. Now, a vector quantity, on the other hand, has both a magnitude and direction. So the scalar quantity just has magnitude, but a vector quantity has both magnitude and direction. So examples of vector quantities, these are, let's say, force, weight, velocity, acceleration, and displacement. These are all examples of vector quantities. Now, how do we represent a vector? An arrow is used to represent a vector quantity. Right? So this is the arrow here. The length of the arrow represents the magnitude of the vector, and the direction in which the arrow is pointing represents the direction of the vector. So for example, if we had a ball, and we know that the weight of the ball, W, will be acting downwards, right? So weight is a vector quantity and it acts downwards, right? Now, what are coplanar forces? Now, coplanar forces are forces that act in the same plane. For example, if we have three forces, we have F1, F2, and F3, and they are all acting in the same plane, as in, let's say, the sheet of paper, right? That is what we mean by coplanar forces. Now, how do we add vectors? Forces that are parallel and acting in the same direction, what do we do? So let's look at this box here. It's being acted upon by two forces, a 2 Newton force and a 4 Newton force, both acting towards the right. So what is resultant force? The resultant force acting on an object is a combined effect of all the forces acting on an object, right? So if we have a 2 Newton force and a 4 Newton force acting to the right, the resultant force is 6 Newtons. We just add because they are acting in the same direction and they are parallel to each other. Now, suppose we have forces that are parallel but acting in opposite directions. So we have an object here and we have 4 Newton acting to the right. We have 2 Newtons acting to the left. So the resultant force in this case is equal to 4 minus 2, right? And the resultant force acts to the right because the 4 Newton force is greater than the 2 Newton force, right? So if you had an object here and we had 2 Newton and we had, let's say, 6 Newton acting in this direction, the resultant force will be in the direction of the force of greater magnitude, which is the 6 Newton, that is to the left, and we have to subtract it. So 6 minus 2 will give us 4 Newton. So the resultant force in this case would be 4 Newton. Now, let's say we have forces acting at right angles to each other. So we have an object here, and we have 4 Newtons acting upwards, and 3 Newtons acting to the right. So if we have two forces that are at right angles to each other, right? These forces are at right angles to each other. What we do, we simply use Pythagoras' theorem to find the resultant force, right? And how we do that is that, right, so this is 3 Newtons here. We're going to complete a parallelogram, right? and this line here represents the resultant force, right? So let's look at a simple calculation now. So we have 4 Newton and we have 3 Newton, and we want to find the resultant force, right? Let's show how we got 5 Newtons. If this length here is 4, then this is 4. So we have a right angle triangle here, and so the length of this side is 4 and the length of this side is 3. So therefore we use Pythagoras' theorem. Let R be the resultant force. So R squared is equal to 3 squared plus 4 squared. Therefore R squared is equal to 9 plus 16. So R squared is equal to 25. In order to find R, we just find the square root of 25, and that is how we got 5 Newtons. Right? So once we have two forces acting at right angles to each other, we simply use Pythagoras' theorem. Now another thing that they can ask you in a question is, at what angle does the resultant force act to the horizontal? Now the 3 Newton force is the horizontal force, and we want to find this angle theta. So again, we have a right angle triangle. This is 4 and this is 3. So we can use, from your trigonometric ratios, we can use tan. This is opposite and this is adjacent. So if you recall from your maths, tan theta is equal to opposite side over adjacent side for a right angle triangle. So therefore we write tan theta is equal to 4 divided by 3. Therefore theta will be equal to tan inverse of 4 over 3, and we end up with 53.1 degrees. Okay. Now suppose we have forces acting at angles greater than 90 degrees to each other. In order to determine the resultant force, we need to construct a parallelogram. So we have a 4 Newton force and a 3 Newton force, and it's acting at some angle theta which is greater than 90 degrees. So in order to determine the resultant, we have to construct a parallelogram, which we do by drawing this length being 3 and this length being 4, and the resultant force would be this guy here, right, which is what is shown in this second diagram, right? So this is a typical type of question that you would get in an exam, but you will have to do this using a construction method. So all you need to do is to construct the parallelogram. So we will say let 1 cm represent 1 Newton. So therefore we're going to draw a line that is 3 cm long. So you're going to draw 3 cm. We're going to measure the angle. In the question they will tell you what the angle is, and then we'll draw another line which is 4 cm long, and then we use our ruler and compasses and construct. We need to get this point here, and once we have this point, we can measure the length of this line here, and this will be the resultant force. Now, a force acting at an angle to the horizontal can be replaced by two forces which are at right angles to each other. So we end up with a horizontal component and a vertical component. So suppose we have a force X acting at some point O. We can replace this force which is acting at an angle theta with two forces which are at right angles to each other. So we can replace this force, this F, by this line and this line, and this disappears. Right? So what we are doing is replacing a force with two components which are at right angles to each other. Right? This is the right angles we are referring to here. So the horizontal component is given by f multiplied by cos theta, and the vertical component is given by f multiplied by sine theta. Right? In an examination, you might be expected to find the horizontal component. All you have to do is drop a vertical line here and just measure this length, and this will give us the horizontal component. To get the vertical component, we draw a horizontal line here, and this will represent the vertical component from here to here. Right? So in an exam, they might give you a diagram, and you have to measure using a ruler the horizontal and vertical component. But you can also use calculation as well. So if you have a small object that is traveling with a velocity of 10 meters per second, as shown below, determine the horizontal and vertical components of its velocity. So we have the velocity is 10 meters per second, and it's acting at 30 degrees to the horizontal. And you want to find the horizontal component and the vertical component. So the horizontal component, that is this here, this is the horizontal component, is given by 10 multiplied by cos theta, which in this case is 30 degrees, so it's 10 multiplied by cos 30. Alright, and that will give us 5 meters per second. To get the vertical component, which is here, it will be 10 multiplied by sine theta, or 10 multiplied by sine 30 degrees, and we end up with 8.7 meters per second. So we can find the vertical component by either using sine or cosine, or we can measure it directly if we are given a diagram. Okay.